Okay, so we are practicing for this communications and graphing test, and there's a few more questions here that I don't feel like that we have talked about quite enough. And so these will be good ones for you to practice with me. Do you see a description along the left-hand side and an empty graph? What if I asked you to draw the graph just from my descriptions, which include limits? Well then, would you, on your notes, please make me a little picture, just an empty graph, and then fill in stuff that you see. Over here, this over here gives you enough info that you can graph completely what this thing looks like. Maybe you start, those top ones are kind of obscure. Maybe you start with like horizontal asymptote at y equals 2. Oh, I know what that is. It's like that. And there's an x-intercept at -1. Okay, I can do that. That's a big dot here. Y-intercept at -1. Okay, well, there's a big dot there. I guess now I'm going to have to do those limit things. So maybe I should read those over carefully. It says the limit of the function as x goes to infinity, that's like way over here, is going to be 2. Now, I don't know, though, whether or not my graph's like coming from the top and getting closer and closer or coming from the bottom and getting closer and closer. I don't know yet. So I'm going to just kind of say, okay, I know it's going to get closer to this dotted line. All right, next thing, this one. The limit as I go way to the left is also 2. Again, it's going to either be coming from down here or coming from up above, but this time I should be smart enough to figure out where it is. Is it below the line or is it above the line? It's below because look, I got these points here. And so it must be going like that. Okay, I got the first part of my graph done. See how it's kind of like a logic puzzle you're putting together? All right, so, and now, you see how this is going down? I bet there's a line that goes up and down somewhere. Look at the next one, and it tells you. Do you get how x is approaching 3? X is approaching 3. That means it's one of these kind of limits. And it's approaching 3 from the negatives, and it goes to -infinity. That's this one right here. Okay, so it's going down, down, down like that. Yes! I'm getting my graph done slowly but surely. Next piece of evidence that I can use logically. As it approaches 3 from the positives, the answer is -infinity. This will answer my question. Is it down here or is it up here? Is it below or above the dotted line? What do you think? It's got to be below because it says that it's gonna, as I get closer to the dotted line, it's going to go to -infinity, which is like this. It's going to go down there. So that means it must be below the line, and that finishes off my sketch. Do I have to know exactly where it goes? Nope. I just need to know that it gets generally in this area and generally in that area. Yes, sir? This would be like, I guess it's probably R3 level, yeah. It's kind of a little bit more complicated. Today I'm trying to go through the more complicated stuff, because the easy stuff, if you can't figure out how to do Bob, Sob, and Bot by now, you better study, because we've gone over that so many times. All right. Here's another one. This time I don't want to explain so much. See if you can do it all yourself. When you were a little kid, you always wanted to prove that you could do it. You probably would say things like, I can do. Hopefully you can. One of my favorite sayings from my kids was always, uppy, uppy. I like reach up like up, up, up. Walk up to me. Now I can't lift my kids. I suppose I could if I had to. The y-intercept is at 3. That's kind of an important one. I'm going to put that on right away. There's a dot right there. Can you tell from these two that there's an asymptote line? That asymptote line must be at what? -1, because it's going to get closer and closer to that as I go to infinity. So -1 is down here. So if it's going to get closer and closer to this, it's probably coming from the top because there's a dot up there. But wouldn't it be nice if I knew the line that goes the other way? The vertical asymptote? Doesn't this tell me the vertical asymptote in this one? Yes, it does. Tells me that at -2, there's a vertical asymptote. So there must be a line like this. Finish it off if you haven't already. Okay, logically, if there's a point right here, then I need to be going like this, and then like that. Okay, and then usually they go like this. How can I be sure that I'm doing it right, though? I look at this kind of stuff, and I say, all right, if the function is approaching -2 from the positives, that means like from over here, then the answer is infinity. Oh yeah, that's this part right here. That's it going up right here. All right, that was good. I already had that part right. Let's check this part. The function, as it approaches -2 from the negatives, is -infinity. That's like coming from over here, going this way, that it should be -infinity. So yep, it's going down there. So then it must be down there. What's the one thing that I have left off and get it marked wrong for? The whole is at is at 2 comma something. So that means I go to x is 2 right here, and I follow it up to the graph, which is right there, and I put an empty spot right there on the line. Okay? So there is my graph, including the whole. Raise your hand if you feel confident you understand that kind of stuff. All right, that's most of you. All right. This one. Is this a possible graph? Now this part you're going to have to get used to. We've been doing exact graphs. But now we're just kind of like looking at this in general. Is this generally look right? Well, there's a few things I can look at. You see how it's negative in front? Does that tell me something? Yeah, going down on the right. Is this one going down on the right? So then check mark, it's right when it comes to that. This one is degree 2. Does it look like I've made a degree 2 thing? Okay, then it's right when it comes to that. What's the last thing I should check? Y-intercept. The y-intercept is supposed to be -1. Is it right when it comes to that? No, it's not, and therefore the answer is no, because y-intercept is off. If I had put this through -1 right there, then I would have said, yeah, that's okay then. My sketch isn't proved wrong by any of these 3 major things. Could somebody else have drawn it like this? Does that still have degree 2? Yes, it does. Therefore, it would have been all right. Okay. What if somebody else said, well, if I can do anything I want, then I want to go like this? Nope, because that one's degree what? Degree 3. 1, 2, 3. And it's supposed to be degree 2. See, and the other thing is, since it's supposed to be degree 2 here, it's supposed to end going opposite, or sorry, going the same direction as the other end. So if you want to cut through, that's fine, but you got to go back down so that this one's going down and this one's also going down. So you see how there's many possible answers? What if a kid wanted to argue that their answer of this was right? Could they argue that that was possibly right? It seems like it has no roots. What if they said there's 2 imaginary roots? Is that reasonable? Yeah, they could argue that. It's kind of outside the box, but you could argue that. All right, how about this? What if the kid says, well then, if imaginary roots can be used, I want to go through this, which you have to, and then I want to touch it once and have the other two roots be imaginary like that. So then I got, how about that one? Is that okay? No, because it's degree 1 plus what if they just say, but I only wanted one imaginary root? Can't do that. You only have, imaginaries always come in sets of 2. And look, it's going up and down. Is that what even things are supposed to be doing? No. So it's not like anything goes. But there are a lot of possible right answers. That just isn't one of them. All right. So again, I'll leave you with one that would have been a good one. Goes through this. Let's say it bounces and goes back down. Now they're going up even. So it goes same direction. Got that? Check. This, it's negative. It's going down on the right. Check. And it goes through -1. Check. All right. How about that one? Is that a possible graph for this problem? Let's take it one piece at a time. The lead coefficient is positive. What does that mean? Up on the right. Check mark. This 5 right here. Is this graph okay when it comes to degree 5? Yep. 2 bounces and a cut through makes 2, 4 plus 1 makes 5. Good there. And it's also odd, which means they're going opposite directions. Good there. How about that guy? +1 for a y-intercept. Sorry, -1. Yep, it's going through there. Check. This one's okay then. It's a possible graph. So possible graph doesn't necessarily mean it's exactly perfectly right, but it checks out in all the major areas. All right. Sketch me a possible graph of that one. There's many possible ways you could do it. Okay, sketch a possible graph. If your graph looked like this and went down on the right and had a degree of 4, which could be like a whole bunch of cut-throughs, could that possibly be a right answer right there? Well, let's check each part. Does this part qualify? Yeah, because it's going down the right. The degree 4, did I do a degree 4? Yep, qualifies there. Oh, wait a minute, where's the y-intercept? The y-intercept is a 0 at the end. There's nothing there, but there's a 0. That means there's a y-intercept of 0. I kind of went through 0, but I was a little sloppy. If I went like this to make it really clear I went through 0, then that's as good. That's good enough. Now, could you do it another way? Yes, there's probably 100 ways that would be right. But you have to check each part. Did you go down on the right? Raise your hand if yours goes down on the right. Okay, good. Raise your hand if yours, I'm curious, did anybody do 2 bounces? Raise your hand if you did 2 bounces. That's a good way to do it. How many of you did 4 singles? Did any of you do 2 singles and then we're going to say that yours had imaginaries? Because you could have. You could have said, okay, I'm going to cut through there, and I'm going to cut through there, and I'm just going to keep going down, and now I would have had to accept that because it's got 2, but it could have 2 imaginaries. That could bring it to 4. It's going down on the right, and as a 0 y-intercept, I'd have to accept that. Yes? All right. So the bounce would have to be at 0. Yep, I'd have to accept that too. Good job. Okay. How about this one? This one is a little different because it says, what are the zeros? What are the zeros? Well, the zeros are, everybody knows this one, -4. Everybody knows that one is 3. But a lot of people don't know what the heck to do with that. Yep. Okay, look. Shh, watch. Look, see? Okay. This one right here, I want to make sure you know what to do with that. That is a same as if I had written x plus 0, and it would make it more obvious that the answer is 0. That is a root 2. Its root is 0. But wait a minute. How can there be, this has a degree 3, 4, 5, plus 1 for that makes degree 6. And yet I only have 3 roots. Is that possible? Yes, it is. Because it could be bounces through them, could be triples like snakes through them. All right, so now to graph it, possible graph, I would need to go to -4, put a dot, because that's one of the roots. There's a root at 0, and there's a root at 3. And then I'd have to do the right things through them. See if you can sketch me a correct possible graph for this one. If you can tell, the thing I think we hadn't spent enough time on in practice was sketching possible graphs. Hopefully you've processed by now that that is a bounce there. So it must be bouncing. It's either bouncing up or it's bouncing down. And, oh wait, there's a negative in front. Has to be going down, so therefore my bounce better not be going up. It better be going down. But then you'd have another root, wouldn't you? And that other root is not listed, so therefore it couldn't do that. See, this is more stringent. Like, you got to follow some rules here, because you can't just, it's not anything goes. I have to be going through these spots, and at the 0 right here, that's a cut through. And then at the 4, it's a triple. Ooh, that's right, those are the ones that look like the snake. They're increasing at a decreasing, and then increasing and an increasing. There's a possible graph for that one. You'd have to be bouncing here. You'd have to be cutting through here. You'd have to be doing a triple, a snake there. And then it has to be going both down, because this is not a degree 5, it's a degree 6. 3, 4, 5 plus 1 makes 6. It's a degree 6, so they should be going the same way as each other. Okay, so there's not as many possible graphs on this one. All right. Another sketch the possible graph. This time you don't know the roots. You've got more freedom again. Hopefully you're getting good at this. I hope you started with this. Okay, it's got to be going down. Next thing I'd look at is that. Say, I got to be going through -2. And then from there, I've got a lot of choices. If I'm going to have degree 5, I like 2 bounces. Bounce, bounce, then a cut through. That would make a degree 5. They go in opposite directions. Qualifies here, qualifies there, because it goes through -2. And it has a degree 5, because it's got that and that and that. You could have done your degree 5 with a triple and a bounce. You could have done your degree 5 with 5 cut-throughs. Triple and 2 imaginaries, very nice. Okay, I think you're getting the idea on those. This one, how could you get the accurate x-intercepts if it's not in factored form? Factor it, exactly. I think you'll find this factors fairly nicely. We didn't give you any really nasty factoring, but you will have to factor. If you do not know how to factor, move back 2 spaces. Do not pass go, do not collect a straight A on test. Hopefully you notice 3x comes out. And then hopefully you notice you can factor it again. And now it'll be easy to graph it. Yes?
On the end of the first one, why isn't there a +0?
If you want to put a +0 there, you can do that.
You still factor it there.
If there's a +0 at the end, you can still factor it and then say +0 out here, can't you? +0 is really not there, but it's just reminding you that it does have its y-intercept is 0. Now, look, when it's in factored form, that y-intercept, or that x-intercept, sorry, is also the y-intercept, is right here. See how that's going to be a 0? And this is going to be a -2. And this is going to be a -2. It's a double. So I've got 1, 2, 3 roots. It's got a degree 3. It's all looking right to me. So it's still got it in this form. It's just it has it in this way. Whereas this one would have it as a y-intercept, but y-intercept and the x-intercept being 0 is the same thing. Okay. So then I'm going to put a dot at -2. And I know it's got a double. See, this is a double. What does that mean? bounce. It must bounce there. And it must be going up at the end because it's positive in front. So I have to be going up here, going through this with a single, and it has to bounce there. And it has to be going down then because it has to be going one up, one down because it's odd. And it has a y-intercept of 0. Yup. There's your graph. Your bounces might be more pronounced. You know, you could have done like that if you wanted to. But you'd have to have a bounce here, cut through here, go in opposite directions, going up on the right. All right, we've done a lot of that. Do you feel confident about these now? All right. If you don't, then that's what you should practice tonight. Yes, sir.
Wait, so would you not be able to cut through and negative and then bounce to 0?
Yeah, you could not do that because you can see from your factoring that that is not a double root. See, when they're in factored form, you can tell what they are, whether they're bounces or cut-throughs. When they're not, when they're looking just like this, then you have a lot more freedom. But if you can factor it, then you can say for sure, that's not bouncing there. That's just cutting through there. This one is a bounce because it's a double. All right. Okay, we're down to the last like 3 things. It's pretty easy from here. This one, if you graph it, would you agree it's just the parent function, except it's been moved which way? Left 2. Okay, so here's what a parent function looks like. And I take, and it goes through like this. Key points there and there. Remember that one? Parent? And I could just move him, the whole thing, left 2. Okay? Good enough. How about this kind? Well, you start by factoring it. Let's do that. Everybody, make sure you're okay at factoring, because that's definitely going to come up. Cancel what you can cancel. And this blue part here will not be on the test. This is just me helping you with, I would recommend that you do these things to graph it. I would factor it first. They will not require you to do those things, but they will say in the directions, we are going to be looking for vertical asymptotes. So all you need is a nice graph that has the vertical asymptotes, the horizontal asymptotes, the x-intercept, the y-intercept. You're going to want all of those things, but on the graph. So if I were doing this problem, I'd go off to the side. I'd start by factoring it. X plus 3, x plus 2, x, and it's probably got a plus 3 or a plus 2 in it because that way it'll cancel. And yeah, x plus 3 and x minus 1. Okay, once I got those factored, that's the whole. And I'd right away, everybody forgets the whole, so I would put it on there and I'd figure out where it is right away. X is -3, comma, y is, you can figure it out. I stick in -3 in here, -3, and I get -1 over -4. -1 over -4 is positive 1/4. So if I go to -3, comma, positive 1/4, I'd put a hole right there, because that's the thing everybody's going to forget. If you do one thing better than everybody else, just remember to put the hole on the graph. All right, next thing, verticals is VD, vertical denominator. That tells me right there what the denominator problem is, and that's if x was 1. So that means that x equals 1. And remember, v's turn into x's, and horizontals are like y's. Bob tells us the answer. All right, x equals 1. Wait, that was y equals 1. Oops. X equals 1 is like this. And then y equals, is this bigger on bottom, bigger on top? Same on both. Same on both, so same on both are a ratio. Lead coefficients are 1 and 1, so it's y equals 1 over 1, just 1. So yeah, there's a y equals 1 asymptote 2. And then the x-intercept on this puppy is where y is 0. I set 0 right here. 0 equals, well then just the top needs to be 0, which is when x is -2. So the x-intercept is at x is -2. There it is right there. That makes sense. It's fairly close to where the hole is. The y-intercept is where x is 0. I stick in a 0 here and a 0 here, and I get 2 over -1, which is -2. So y is -2. It touches right there. Does that make sense? Yeah, because it's probably going like that. There. And my guess is that this other side's going like this. But how do I be sure? XY chart. I make an XY chart. I pick some points over there, like if X is 3, I see where it is. If I stick in a 3, 3 goes in here, and here, and here. Oh wait, I could do that, but it'd be way faster to just do it in the factored form. Here, and here. 3 plus 2 is 6, no 5, over 3 minus 1 is 2, 5 over 2 is 2.5. So 3 is at 2.5, and there it is. In fact, I hit it exactly. What are the odds of that? So it is up there. And I could test some other points if I wanted to be sure, but that's basically what your graph looks like. Any questions on that? Yes, sir?
So you only proved 1 point?
If you proved 1 point up there, you'd be good enough, because I'd know from there that the graph can't like cross over here. It's only going to do that if there's 2 vertical asymptotes. So it can't cross over. So it's kind of trapped that if it's here, it's got to get closer and closer to this line and closer to that line. There's only one way to do that. So that's it. Prove 1 point, you're good enough over there. If you want to be sure, though, that you didn't goof it up, maybe you try another point. And if your other point is like here, then it's like, oh, it's really obvious I know I'm right. Okay. All right. So this is important because the wording is weird. See if you understand which limit I'm talking about. There's 4 ways to do a limit for this picture. In fact, there's 6. There's the way right end, the way left end, and this time there's 2 lines in the middle you could be heading towards. See if which... Actually, it should be an S in here. Limits describing the graph's behavior near the vertical asymptote 1. Where is the vertical asymptote 1? It's that one, the red line. So it's talking about limits that are right for this and for that. So I need always start with lim of the function as x approaches, and then I put an equals, and I just need to fill in this and this. So for the 2 that I have here, I'm getting really close to 1, and I have to come from the positives and from the negatives. So I'm going to start by going with 1 from the positives. So I'm starting over here, and I'm going to get closer and closer to 1, and then it sucks me up this way, positive infinity. If I do the lim on the other side of the function, as x approaches 1 from the negatives, I'm over here, and I'm getting closer and closer to 1. I go this way, and it pulls me up also positive infinity. Positive infinity. There's the one. There's the other. Any of you have it right? Good. Okay. Assume that's the parent function. Could you write me an equation that would follow these changes in order? Y equals absolute value of x. How do I do the right 5 thing? Minus 5. How do I do the 3 times wider thing? Wait a minute, isn't a 3 in there? No, because that would make it 3 times narrower. Does the counterintuitive thing. So 1/3. Okay, reflect over the x. That's an up, down, no, wait. Yeah, up, down flip. So which way is that? Negative where? Outside. There I am. Now one kid asked last hour, could I have done this? That changes the order around, doesn't it? Would this list do that in the right order? I'm supposed to be doing right 5 first. The way I would answer this question is I'd look at this and I'd say, okay, normally you do parentheses first, so we should do this first. The way he wrote it, I would had to have had the 1/3 being first. So no, you couldn't have parentheses. That would goof it up. For the way I want this one to work, this was right. Because I would say, well, normally multiply comes before subtract, so I will do the subtract first, and that's what is first, and so it's in the right order. Okay, and the last thing, you've made it to the end. Here are some numbers. Would you know how to put them into list 1 and list 2? Would you know how to find either linear regression or quadratic regression? How about if we asked you about cubic regression? Pretty much the same thing. Look on your calculator. I want you to see it once. Don't even have to put the data in. Everybody go look at your calculator right now. Go under Stat, Calculate, see if you can find cubic reg. All right. Okay. Do you generally know where that is on the menus? All right. All right. The main point is, if you know where that is there anybody that is not seeing it? Is it right underneath quadratic? Is cubic the next one? Okay. All right. We'll do one of those problems tomorrow. But generally, if you know where that is, I think you now know absolutely everything you would possibly need to know. All right. The homework for tonight is to finish the worksheet I only gave you the front page of. Finish it. Does it have to really be done by tomorrow? Not really. But don't, if you got time tonight, do it, because you're going to have to get it done by Thursday. So it doesn't really have to get done tonight, but it'd be smart if you got the time. Finish your worksheet.